Yeah, good afternoon, children. So, before we have completed lecture 3, I think so lecture 3 we have completed, or any problems are there still to explain? I told to complete this lecture 3. Okay, only substitutions I said, just when you substitute, if you get remainder 0, then it is a factor, otherwise it is not a factor. Only depends on only the condition factors, whether it is a factor or not. Given like x plus 3 is a factor of p of x or not, x minus 3 is a factor of p of x or not. Just we have to substitute in place of x3, like x plus 3 equal to 0 we have to take, and x values we need to substitute in the given polynomial. If we get remainder 0, it is a factor, otherwise it is not a factor. These things we have studied in before class, that is up to lecture 3. Okay, now coming to lecture 4. See, lecture 4, page number 57. Page number 57. Zero of polynomials. Zero of polynomial. Okay, so zero of polynomial means, see, suppose let p of x is a polynomial. Let p of x is a polynomial. Okay, the x coordinates of a point, x coordinates of the points called zeros of polynomials. The x coordinates of the points called zeros of the polynomial. See, through graph, very easily we can show it through graph. Suppose if one graph, we just observe maximum in 10th class textbook, we observe 9th class students, we observe in 10th class textbook polynomials chapter exercise 1, first exercise. So if you observe there, find the number of zeros, like that you will ask. So the image polynomial, the graph where the graph is touching the x-axis, only the x coordinates will become the zeros of polynomial. So that is the reason. See, let p of x is a polynomial, the x coordinates of a point called zeros of the polynomial. X coordinates means, suppose if I say 2, 3, this is x coordinate and this is y coordinate. And suppose if I take minus 1, 5. Okay, again in this x is -1 and y is 5. Okay, these are x coordinates and y coordinates. Means always this is called an ordered pair. Okay, this will become another subject, but just ordered pair. Ordered pair means placing x coordinate and y coordinate in a small brackets. Okay, it is nothing but an ordered pair. In that, this always the first term will be called as an x coordinate or abscissa. Sometimes abscissa also we can call it. And second term will be called as a second coordinate or y coordinate or ordinate. Ordinate we call it. So why in just I am showing this zero of polynomial in terms of graph. In terms of graph, how can we define this? Suppose this is -3, 0 points. Suppose this is -1, 0 points, and this is 1, 0 point, and this is 3, 0 point. Because see, always the points on the graph means the points of the graph, always y values will be 0. Always, but that y values will be 0. Suppose like this graph is there. Suppose -3, 0, -1, 0. The coordinate points are this one, 1, 0, okay, and 3, 0. So how many zeros are existing? What are zeros? That means I told you what are zeros. Normally, up to 7th class, what we call for the zeros means roots or solutions we used to call. But coming to the 9th class And in IIT books, we don't call it as a root or solution. We call it as a zeros. Why we call it as a zeros? Because when you substitute these values in the given polynomial, the remainder becomes zero. Understand? The remainder becomes zero. So that is the reason. So we call them as a zeros. Why? Because their zeros are nothing but roots or solutions. Okay, roots are solutions. See here, the number of zeros equal to how many zeros? One touching point means where the graph is, this curve is touching the x-axis, all the touching points are nothing but a zeros. Right? See, here the curve touches the x-axis here. Here curve touches the x-axis here. Here curve touching the x-axis here. Again the curve is touching the x-axis here. Means how many zeros are existing? 4 zeros are existing. Okay, 4 zeros are existing for the given graph. What are the zeros means we can write. Here only the x coordinates we have to take. What are means we are showing the zeros means only the x coordinates we have to write. Here x coordinate is -3. Here x coordinate is -1. And here x coordinate is 1. And here x coordinate is 3. So -3, -1, 1 and 3. These are the zeros of the given polynomial. Understand? These are the zeros of the given polynomial. So suppose if the graph is like this. Suppose if the graph is like this. Means the given curve does not touches the x-axis. Okay, the given curve is not touching the x-axis. When the curve is not touching the x-axis, here we can say that zeros does not exist. Zeros does not exist. Does not exist. Okay, zeros does not exist. Why it does not exist? Because when the zeros can form, I said, if the curve touches the x-axis, only the x coordinates can be called as the zeros. But as your curve is not touching the x-axis, how the zeros can form? Because x coordinate doesn't form. Understand? So where this curve is touching the x-axis, there you will get a point like x coordinate and y coordinate point you will get. In that x coordinate we take it as a zeros. Understand? But here the curve does not touch the x-axis. When the curve does not touch the x-axis, here zeros does not exist. No zeros we write. Zeros does not exist and no zeros we write. Here. Next, some useful relations. Okay, some useful relations. What are useful relations? See, some useful relations. Okay, simple things. A plus B whole square. Sir, I know sir very well. I am 9th class student. A plus B whole square. I know it sir very well. Yes, okay. A plus B whole square. What do you write for A plus B whole square? A square plus 2AB plus B square. But here I can write A minus B whole square plus 4AB. Yes, can I write or not? A minus B whole square plus 4AB. How, sir? Okay, A minus B whole square plus 4AB. See, why we can write like this? Because in A minus B whole square can be write as A square plus B square minus 3AB. Are you getting my point? A minus B whole square can be write as what? A square plus B square minus 2AB. This minus 2AB, this plus 4AB. Minus 2AB plus 4AB. It will become plus 2AB. Yes or not? Let me solve that. See, suppose I am saying that this is one of the formula. Let me complete this. A minus B whole square, normal formula. What is the A minus B whole square? A square plus B square minus 2AB. A square plus B square minus 2AB. And this plus 4AB. Okay, A square plus B square minus 2AB. And whatever the plus 4AB is there, plus 4AB I have taken. So I just move it down. Okay, so right. So A square plus B square minus 2AB and plus 4AB. Right? plus 4ab. Now in this you see a square plus b square minus 2ab plus 4ab. This is minus 2ab, this is plus 4ab. See, both are ab terms. One is plus, one is minus, means we have to do subtraction. So, but 4 minus 2 how much? 2. 2ab. Biggest number is 4, it contains plus sign, no? So keep plus sign. So what is the formula? A square plus b square plus 2ab, which is nothing but a plus b whole square. So by this, what do you say? A plus b whole square can be write as a minus b whole square plus 4ab. Understand? A plus b whole square can be write as a minus b whole square plus 4ab. And number 2, we can write same way. A minus what? A minus b whole square can be write, sir. What? A minus b whole square can be write. So a minus b whole square can be write as a plus b whole square minus 4ab. Yes, a plus b whole square minus 4ab. Because see here, a plus b whole square is nothing but a square plus b square plus 2ab plus 2ab and minus 4ab. Plus 2ab and minus 4ab will become minus 2ab. So it will become a square plus b square minus 2ab. Getting my point? Just see. Again, I just solve it. A square plus b square plus 2ab. This plus 2ab and this is minus 4ab. We have no. This is minus 4ab. Now see, a square plus b square plus 2ab and minus 4ab can be written as one is plus sign, one is minus sign. Both are ab terms. One is plus sign, one is minus sign. One is plus sign, one is minus sign, means we have to do subtraction. So 2 minus 4 is 2. 2 and biggest number is 4. It contains minus sign. So I'm just keeping minus sign. So it will become a square plus b square minus 2ab. So by this we can say that a minus b whole square can be write as a plus b whole square minus 4ab. Okay, very important thing. So a plus b whole square can be write as a minus b whole square plus 4ab, and this a minus b whole square can be write as a plus b whole square minus 4ab. Right? And coming to 3, a square plus b square. A square plus b square. What do you write for a square plus b square? A plus b into a minus b. Oh, many things we can write. A plus b into a minus. Yes, a plus b into a minus b is a square minus b square, you know. So we can write this a plus b into what is a minus b? We can write under root of a plus b whole square minus 4ab. Can I write? Observe it little. Okay. See what I can write. See what is a minus b whole square? A minus b whole square is a plus b whole square minus 4ab. If I remove the root, if I remove the square, here root comes. Yes or not? As I remove the square, what comes here? Root comes. So a minus b is equal to what I can write? Under root of a plus b whole square minus 4ab I can write. So that is what I wrote. In place of a minus b, what I wrote? Under root of a plus b whole square minus 4ab I wrote. Understand? Still, now what you can write? Now a plus b is there, no? Here a plus b whole square formula also we have. Here also if I remove the square, okay, if I remove the square, again here root comes. Understand? As I remove the square, what I get here? Root I get. So a plus b, what is a plus b? Can write root of a minus b whole square, a minus b whole square plus 4ab again into root of a plus b whole square minus 4ab. Understand? So these are what type of formulas. You see how many formulas will be existed. I'm trying to show how the number of formulas will exist in this. Understand? So this every step is a formula. Even a square plus b square can be write as a plus b into a minus b, or else a square plus b square can be write as a plus b into under root of a plus b whole square minus 4ab, or else a square plus b square we can write as under root of a minus b whole square plus 4ab into a minus b also we can write, or else same as this we can write. So these many formulas we can create with only one formula. Understand? So next we can write what is the another formula? Fourth one, a cube plus b cube. What actually a cube plus b cube formula? See, a cube plus b cube means a plus b into a square minus ab plus b square is the formula. Yes or not? What is a cube plus b cube? A plus b into a square minus ab plus b square is the formula. But we can write this formula as, see, we can write this formula as, okay, we can write this one as a plus b whole cube minus 3ab into a plus b also we can write. Minus 3ab into a plus b also we can write. Okay. Don't want that much depth. Okay. Just what is a plus b whole cube formula? Is a plus, I mean a cube plus b cube formula is a plus b into a square minus ab plus b square. Then what about a cube minus b cube? A cube minus b cube is a minus b into a square plus ab plus b square. What is this? A cube minus b cube is a minus b into a square plus ab plus b square. Right? Copy. Make it fast. Erasing sides. Yes, shall I? Or I have to wait for one or 1 minute. Yeah, I'm erasing this side. Now see, division algorithm. Division algorithm. Division algorithm for polynomials. Okay, what is the division rule? Suppose P of X is a dividend. Dividend. Okay, if P of X is a dividend polynomial, G of X is a divisor, Q of X is a quotient, and R of X will become remainder. Getting my point? P of X is a dividend, G of X is a divisor, Q of X is a quotient, and R of X is a remainder. Okay, R of X is a remainder. Now, what is the division rule we can write? P of X is equals to G of X into Q of X plus R of X. Yes or no? So what is the division rule actually? This is called dividend. This is called what? Dividend. D-I-V-I-D-E-N-D. Dividend. And this is called divisor. D-I-V-I-S-O-R. Divisor. And this is quotient. Q-U-O-T-I-E-N-T. Quotient. And this is remainder. Remainder. Understand? So by this what we can say is dividend equal to dividend equal to divisor into quotient plus remainder. Okay, this is the division rule actually. So divisor equal to quotient plus remainder. P of x is equal to g of x into q of x plus r of x. That is dividend equal to divisor into quotient plus remainder. Right? Suppose in this only we have 0 of polynomial. What is this? 0 of polynomial. What actually we find 0 of polynomial means whatever the polynomial is given. Okay. To that polynomial, you have to make equal to 0. You have to equate it to the 0. When you equate it to the 0, what do you find from that means? We will find the unknown value. Unknown value is nothing but it will be the variable. Any of the variable like x value or y value or p value or z value or c value, whatever it is. Whatever the variable unknown value lies inside the polynomial, that value you will find. Like example, see, example, p of x is equals to 3x minus 9. Okay, find the 0 of polynomial. Find the 0 of polynomial. Okay, find the 0 of polynomial. So what do you write here? See, so 0 of polynomial we have to find means p of x equal to 0. What I said, whatever the polynomial has given, equate that polynomial to 0. Okay, equate the polynomial to the 0. So which is 3x minus 9 equal to 0. Here the unknown variable is x. Following? Here the unknown variable is what? X. So here we find the value of x. So 3x equals to, if minus 9 comes here, it will become plus 9. So x equals to 9 by 3. So which is 3 3s are 9. So value will be x value will be 3. Means here the unknown value is x and we found the value of x. Following? We found the value of x. So sometimes the p, q, anything it may be. Okay, anything it may be. So what if he is asking to find the value, find the 0 of polynomial means there we need to find one unknown value or one variable value we need to find. Understand? Suppose example 2. P of x is equal to 2 cube minus 2 cube plus 10. Find the 0 of polynomial. Find the 0 of polynomial. Okay, as I said you before, any polynomial equate it to 0. So if you equate it to 0, p of x equal to 0. That is 2 cube plus 10 equal to 0. Here the unknown value is q and which is also a variable. So that value we find here. So 2q equal to, if plus 10 comes here is minus 10. Q equal to minus 10 by 2. Because into is there, it comes to denominator. 2 ones, 2 5. So q equal to how much it is? Minus 5. So in every problem, 0 of the polynomial we have to find means there we find one unknown value or one variable value we have to find. Right? Copy this. Actually, I thought to I spoke with you, but here some audio problem was there. Okay, so let us talk tomorrow. Let us discuss tomorrow. Some things are there to discuss with the children and with the teachers who are along with the children in this IIT classes, and the IIT coordinators also. I need to discuss some matter or information about the children, how they are studying, are they maintaining the book, are they following the classes, they have any problem with the classes, are they facing any difficulties in understanding the subject. If they are facing difficulties, what is the problem and where they are lacking, that I must know it very clearly. So tomorrow we'll discuss this all. So just copy this So by tomorrow, our problem will be rectified. So we'll discuss it tomorrow. Copy. Those have completed, you can move from the online. Copy fast and move. Make it fast and move. It's almost 3:30.